Welcome to solverfy.
So here we're trying to find the phase constant given that we have different initial positions. So the general formula will be x equals a cosine of the angular velocity times t plus the phase constant phi. We know that for part A, x at 0 seconds, or the initial position, would be equal to negative a. So negative the amplitude times, of course, -1. So here, negative a would be equal to a cosine of phi, because here we're plugging in 0 for t, because this is applies to the initial position, and the initial position is, of course, where t equals 0 seconds. So negative a will be equal to a cosine of phi, and then we know that phi will be equal to arc cosine of -1, and this is going to equal pi. So the phase constant for part A is pi, and then for part B, the initial position is 0. So x of 0, x at t equals 0 seconds, will be equal to 0, which means that 0 equals a cosine of phi, and we know that phi is going to be equal to arc cosine of 0, or this is going to be equal to plus or minus pi over 2. For part C, we know that the initial position now is not negative a, but positive a. So 0, we can say a equals a cosine of phi, which means that phi is going to be equal to arc cosine of +1, and this will equal 0. For part D, the initial position is going to be equal to positive a over 2. So essentially phi is going to be equal to arc cosine of +1 over 2, and this will be equal to plus or minus pi over 3. For part E, the initial position is now negative a over 2, which means that phi will be equal to arc cosine of -1 over 2, or we can say plus or minus 2 pi over 3. And lastly, for part F, we know that the initial position at t equals 0 seconds is going to be equal to the amplitude divided by radical 2. So this means that phi will be equal to arc cosine of 1 +1 divided by radical 2. And we find that this is going to equal plus or minus pi over 4. So essentially, this would be how you would find the phase constant of all of these different initial positions, and the ambiguity in some of the answers. So we have plus or minus here, plus or minus here. The only answers that are not ambiguous are part A and part C. This is going to definitely equal pi, and this will definitely equal 0. However, because we don't know the direction of motion at t equals 0 seconds, we can't surely say if part B, part D, part E, and part F are going to be the positive term or the negative term. So because we don't know the direction of motion, initially we can't specify the positive or the negative term. That is the end of the solution. Thank you for watching.